Good morning, students. Welcome to the class of chemistry. In our series of basic concepts of chemistry, we are studying about the concepts on which the whole organic chemistry depends. In our previous video, we had discussed about the electronegativity, electropositivity, and electron affinity of an element. In continuing that series, today we will discuss about the hybridization. Now, what is hybridization? Hybridization is the intermixing of orbitals. As we all know, the whole organic chemistry is basically depends upon the carbon compounds, and carbon has the ability to do catenation. Now, what is catenation? Catenation is the carbon's ability of self-linking. Means carbon shows maximum catenation. Means carbon forms maximum number of bonds with itself. That is, carbon forms three kinds of bonds with itself. That is, carbon-carbon single bond, carbon-carbon double bond, and carbon-carbon triple bond. According to which, carbon has three kinds of compounds, that is alkanes, alkenes, and alkynes. In alkanes, there is carbon-carbon single bond. In alkenes, there is carbon-carbon double bond. And in alkynes, there is carbon-carbon triple bond. And as we all know, whenever single bond forms, there is the formation of sigma bond, which forms due to the head-to-head overlapping of the compound of an element. While the other bonds, that is in carbon-carbon double bond and in carbon-carbon triple bond, in carbon-carbon double bond there is one bond, and in carbon-carbon triple bond there is two bonds which are formed pi overlapping. By pi overlapping means the side-wise overlapping. And when we talk about the side-wise overlapping or head-to-head overlapping, that is in sigma bond or in pi bond, head-to-head overlapping covers the larger extent of area. That means that bond is more stronger than the side-wise overlapping that is occurring in pi bond. Due to which the pi bond has the ability to join with another compounds easily. Or we can say, when the formation of bond occurs in a compound, the pi bond will break first. And that also means when a carbon compound has a pi character in it, that also show the electronegative character. Means sp2 hybridization and sp3 hybridization carbon compound has more affinity towards the gain of bonded electrons. Now I am explaining you diagrammatically about the things I have already told you. Let's start with this. Let's take an example of carbon atom. We know carbon has atomic number 6. So its electronic configuration will be 1s2, 2s2 and 2p2. In ground state, its orbital representation will be, in s orbital we know there is only one subshell, and in p orbital there is 3 subshells. When a carbon atom goes into the excited state, its one electron will transfer into its p orbital and all the 4 orbitals become half-filled orbitals. As we all know, carbon forms 3 kinds of compounds: alkanes, alkenes and alkynes. In in alkanes there is carbon-carbon single bond. In alkenes there is carbon-carbon double bond, and in alkynes there is carbon-carbon triple bond. When carbon-carbon single bond is present, that bond is only a sigma bond. With carbon-carbon double bond in alkenes, there is one pi bond and the other one is sigma bond. And in carbon-carbon triple bond, there is two pi bonds and one sigma bond. And according to the presence of pi bonds, these both carbon compounds will gain partial electronegative character. This character I will explain you according to the hybridization. Now, what is sigma and pi bond? According to sigma bond, there is always head-to-head overlapping. There is an overlapping between two s orbitals, and if there is head-to-head overlapping between p orbitals, then it will overlap like this. P and p orbital, and these two are of kind sigma bond. And in pi bond there is always a sidewise overlapping. It is a pi bond. And according to these three diagrams, it is observable that when the bond is formed with the sigma bond or sidewise overlapping, there is more extent of overlapping which makes sigma bond a stronger bond. While in pi bond, there is always a sidewise overlapping which makes it lesser stable than sigma bond, and this pi bond adds to the electronegative character. And when the bond formation occurs, this pi electron will participate in bond formation. Now let's take a look for the formation of or hybridization of the carbon compound. Let's start with the hybridization of alkanes. As I have told you, the carbon in its excited state has one electron in each of the four valence subshells of it. Let's take an example of alkane, be methane. By methane means its chemical formula is CH4. When hybridization occurs, now atomic number of hydrogen is 1, so its electronic configuration is 1s1. There are 1 electron of carbon in each subshell. Now let's add these 4 hydrogens in all these 4 subshells. So this is hydrogen, this is hydrogen, this is hydrogen, and this is hydrogen. It is carbon's 2s1 orbital and hydrogen is 1s1 orbital. It is carbon's 2px1, 2py1 and 2pz1 orbital. And the hydrogen's orbital is 1s1, 1s1 and it is also 1s1. Now look, there is intermixing of different orbitals. It is 1s orbital and it is 2p orbital. Clear? And what I had told you about the definition of hybridization. Hybridization is the intermixing of different orbitals in a compound. So how many orbitals are taking part in the hybridization? 1s and 3p orbitals. So its hybridization is 3sp, 3 hybridization. Clear? Now the general formula for alkanes is CnH2n plus 2. Now let's take an example of alkenes. For example, ethene. Its chemical formula is C2H4. First, we will draw the excited state orbital diagram of carbon atom. As there are 2 carbon atoms involved in this structure, so we are using 2 carbon atoms. Now what will happen? Carbon-carbon single bond will form by overlapping this orbital, and carbon-carbon pi bond will form after overlapping this. Now 4 orbitals are left. In these 4 orbitals, these 4 hydrogen atoms will accommodate and form sigma bonds. Now how many orbitals are involved in overlapping? This one s orbital and these 2 p orbitals are involved. So its hybridization will be sp2 hybridization, and its chemical formula will be carbon-carbon double bond, as this carbon-carbon one bond and this carbon-carbon second bond is formed, and 4 hydrogen atoms will accommodate here. Clear? So its hybridization is sp2 hybridization, as 1 s orbital and 2 p orbitals are involved in hybridization, or we can say in overlapping. The general formula for alkenes is CnH2n. Now let's take an example of alkynes. In alkynes, there is C2H2. In this compound, there is overlapping of 2 different carbon orbitals in p and 1 in sigma. That means here carbon will overlap with the 3 of its own electrons, in which 1 bond will be sigma bond and other 2 will be pi bonds, and the 1 orbital, or we can say 1 orbital of each carbon atom is left unbonded, and it will bond with hydrogen atoms. Clear? So now these 2 hydrogen atoms will form sigma bond, and these 2 carbon atoms will form pi bonds. Now how much overlapping is occurring between 2 different orbitals? One is s orbital and one is p orbital. So its hybridization will be sp hybridization. So carbon-carbon triple bond will have 2 pi bonds and 1 sigma bond, and with hydrogen it will also have sigma bonds. So now we have studied sp3, sp2 and sp hybridization. In sp3, s character is 33.3% and total p character is 66.6%. In sp2 there is 75% p character, and in sp hybridization there is 50% p character. So there is regular decrease in p character according to the hybridization of carbon compounds. With the decrease in p character, electronegative character of a compound increases. Now why? Because the s orbital always lies closer to the nucleus of an atom, and nucleus tries to keep its electrons more tightly towards itself. So hence the p character, or we can say the electronegative character of carbon compound, depends upon the p character present in its hybridization. Clear? So now, after studying hybridization, you will be able to answer why different compounds of carbon atom react differently in organic chemistry. If you have any query regarding any kind of concept in physics, chemistry and mathematics, do comment in the comment section, and also provide me with your feedback so that I can improve the concept clearing to you, so that you can understand more clearly about it, and we can easily move from our journey of fear towards the journey of curiosity in science. Thank you, students. Stay tuned for more interesting concepts of chemistry for studying in my class. Thank you.